In Pompeii, a specialist team is searching the ancient soil.
We found two very strong signals, really very strong signals.
They are not on the hunt for archaeological treasure here,
There is a high likelihood that it could be a bomb.
but for a deadly relic of the more recent past.
From the instruments, it seems that there is a magnetic response in that area.
Probably there is an unexploded bomb.
Pompeii, the victim of one of the ancient world's greatest catastrophes. In 79 CE, the nearby volcano Mount Vesuvius catastrophically erupted and sent a cloud of hot ash and gas some 20 miles into the air.
You can imagine how terrifying were the citizens of Pompeii when they look at this enormous eruption.
This was a cataclysmatic event that brought the town to complete stop. A lot of people died.
The entire Roman city was buried beneath millions of tons of rock and ash.
This is why it is so well preserved.
Pompeii was rediscovered in 1599. It is the world's most astonishing archaeological time capsule.
When the eruptive column collapsed, all the material emitted completely covered the city of Pompeii under more than 7 meters in thickness.
Pompeii is a window to life in the Roman world. A magnet for archaeologists intrigued by the mysteries of this ancient civilization. Physicist Franco Porcelli is a pioneering investigator. His work fuses geophysics with archaeology to explore ancient mysteries. Today, he and his team are in Pompeii gearing up for a unique mission, using high-tech equipment to search for some extraordinary remains.
Well, of course, we are in Pompeii. You look under the ground, you discover something of archaeological interest.
Franco's
to scan Tutankhamun's tomb.
His team used ground-penetrating radar technology to scan for hidden voids behind the walls of the Boy King's tomb. Their analysis conclusively proved there are no secret chambers in the tomb. Now, authorities at Pompeii have called in Franco to search for something that could pose a real risk to this World Heritage Site. Franco works with Gianluca Vitaliano, an architect and expert on the cultural heritage of Pompeii. Together, they are on a dangerous mission to find evidence of a different cataclysm that struck Pompeii almost 200 years after the catastrophic eruption. The investigation starts at the House of the Faun, once one of Pompeii's most luxurious villas.
C'è l'opera di ricostruzione e questo è il segno di fin dove si era conservata la muratura antica. Tutto questo è stato ricostruito.
Certo, certo.
This modern reconstruction reveals more recent damage to this ancient villa. Gianluca finds evidence of the cause of this damage.
E questa è ciò che resta di una bomba
Sì.
che è esplosa.
This is what we are looking for.
The rusted remains of a huge bomb reveal a shocking episode in Pompeii's secret history.
This is a 500-pound bomb. It was American.
This bomb was dropped on Pompeii by an American aircraft during the Second World War.
Questa è la scheggiatura delle bombe.
Restoration teams have worked hard to repair the damage here. The villa may look like ruins now, but after the American bombing, it was in tatters. Pompeii was hit by many bombs that were dropped during World War II. 150 yards away, the house of Appidius Rufus was reduced to rubble. Today, telltale traces of bomb damage can be found throughout Pompeii.
Franco, qui siamo nella casa di Trittolemo che è stata completamente distrutta dai bombardamenti. Tutto questo è andato tutto perso, mentre qua sul fondo si iniziano già a vedere questa colonna.
Some of the worst bomb damage was here, in the ancient house of Triptolemus. Pompeii's greatest archaeological treasures bear witness to the bombing. Gianluca and Franco continue their investigation at the beautiful House of the Library.
Vediamo che almeno 2 bombe hanno colpito questi ambienti.
Gianluca searches for signs of damage left by the first bomb.
Eccoci qui. Qui siamo all'interno del cratere della deflagrazione, quindi la bomba arriva da quel lato, probabilmente penetra fino a qui, deve essere poi deflagrata in questa zona e qui insomma manca un pezzo di muro e soprattutto ci sono questi muri che sono stati spostati dalla potenza dell'esplosione.
The bomb exploded with huge force and caused significant damage. The room still bears the scars almost 80 years after World War II.
E qui c'è l'altra deflagrazione, ma a differenza di quella, la bomba deve essere esplosa più in basso.
The facts are clear. Pompeii was struck by multiple bombs. On August 24th, 1943, 1900 years after it was devastated by the eruption of Mount Vesuvius, Pompeii was hit by another firestorm. Bombs started raining down on the ancient city. They exploded in the streets, wreaking havoc with the priceless Roman architecture. In 5 weeks, Allied aircraft dropped over 160 bombs on Pompeii. Gianluca wants to understand why this historical treasure was bombed, while Franco's mission is to check Pompeii for any unexploded bombs. Up to 1 in 10 of all bombs dropped during the Second World War failed to detonate. And it's estimated that at least 10 unexploded bombs remain here.
Because the trigger that detonates these bombs becomes more and more fragile with time, and so actually the danger of spontaneous detonation increases with time, so it is an obligation to find this bomb.
The potential bombs are too far from visitors to pose a risk, but they should be detected, excavated and defused as soon as possible.
It has become like a mission now. This really motivates my work here in Pompeii.
The bombs that dropped on Pompeii in 1943 carried between 500 and 4,000 pounds of high explosive. They either had a fuse triggered by impact or a mechanism that delayed the detonation. In these bombs, a small wind turbine spun while the bomb fell, turning a screw designed to break a glass vial and release a stream of acetone onto a membrane. This set off the fuse so that the bombs would explode after a defined time. Why might they have failed to explode here in Pompeii? Alessandra Pensa is a geologist and an expert on the stratigraphy of areas hit by volcanic eruptions like Pompeii. She's on a mission to find out if it's to blame for unexploded bombs here. Alessandra has special access to investigate the House of the Chaste Lovers. She examines the layers of rock exposed here for clues.
Here we can see a beautiful representation of one of the most rare outcrops representing both of the phases characterizing the eruption of the volcano.
Pompeii's unique stratigraphy is caused by the eruption of Vesuvius. It lasted for 18 hours. The volcano first spewed out a cloud of gases and minerals. It rose to form an almost 20-mile-high column of ash and then collapsed.
During the fallout phase, we had a deposition of about 12 to 15 feet of pumice deposit. These pumice deposits are at the base white in color, while at the top they are becoming more gray.
The collapsed column formed a violent surge of volcanic debris, ash and gas, known as a pyroclastic flow.
On top of this phase, we have this beautiful wave shape. We have ash deposits that reflect exactly the moment where the eruption column starts to collapse.
The material from the pyroclastic flow covered the soft pumice and formed a layer up to 6 feet thick over Pompeii.
This hard layer is now called thunder or tuono.
The hard thunder layer could be part of the reason some bombs did not explode when they fell here, but only because it's covered with a soft layer too. The famous 79 CE eruption is not the only one to hit Pompeii and leave layers. Between 79 CE and World War II, Vesuvius has erupted over 30 times. This footage, from 1944, captured the last eruption of Vesuvius. Some of these eruptions have left deposits of soft pumice on top of the hard layer. The alternating soft and hard layers of Earth here played havoc with the dropped bombs' detonation devices. Bombs dropped by Allied aircraft were designed either to explode on impact or to pierce the soil and explode underground. But Pompeii's alternating layers of hard and soft soil could force bombs on an upward trajectory. This would tip the vial of acetone into an upright position and prevent the bomb from exploding. Franco and his team begin their work in an area just over 100 yards from the nearest excavated sections of Pompeii. It's surprising, but only 2/3 of Pompeii's vast 163 acres has been excavated.
In the excavated region, most likely the bombs exploded because they hit the structure of the houses. We looked at areas which are not excavated, and it appears that we have some signals which could have been caused by bombs.
Gianluca became intrigued by the Allies' bombing of Pompeii because it was his job to repair some of the damage.
Negli ultimi 20 anni c'erano stati una serie di crolli in alcune zone di Pompei. E ho riscontrato una cosa abbastanza strana, e cioè che i crolli avvenuti negli anni 90-2000 in linea di massima coincidono con zone che sono state bombardate.
In 2010, the Schola Armaturarum, the headquarters of Pompeii's gladiators, collapsed 67 years after it was hit by Allied bombs. Gianluca is now on a mission to find out why the ancient ruins were hit.
Ho iniziato un attimo a farmi delle domande. Che cosa effettivamente è successo? I documenti che c'erano non erano spesso molto chiari, per cui ho pensato che fosse utile ricostruire cosa è successo in quel mese di bombardamenti.
In 1943, Germany occupied much of Europe. Italy was in league with them, but in July that year, the Allies captured the island of Sicily. They used it as a springboard to launch an assault on the Italian mainland. They first landed in the south. Then a second, larger force headed straight for the port town of Salerno, just 21 miles from Pompeii. A radio report detailed the fighting around Pompeii.
This is Matthew Halton of the CBC, speaking from Italy.
It's the words of a reporter from the Canadian Broadcasting Corporation.
I watched the battle from the walls of the Roman amphitheater outside Pompeii.
He described the reason why Pompeii was hit.
There were German positions on the edge of the ruins which had to be bombed. And one bomb made a direct hit on the Marine Gate, the main entrance, so that now you have to scramble into the ancient city through Roman rubble.
Remarkable newsreel footage reveals that the ancient Roman amphitheater was also struck in the bombing raids.
Qui si dice che i danni provocati all'anfiteatro, c'è un grosso cratere nell'arena, sono stati determinati dalla presenza di truppe nemiche.
The Allies claimed the Germans had guns in Pompeii. Its ancient buildings could provide cover, and the Germans may have thought the Allies would never bomb this historic site. The advance of the Allies put the ancient city in jeopardy. It might have made sense for the Germans to wheel in their guns, but Gianluca's investigations led to a different conclusion.
La ricerca ha dimostrato, anche attraverso il confronto delle fotografie aeree, che all'interno dell'arena non c'era nulla, non era collocata alcuna batteria antiaerea né truppe posizionate in quel punto.
Gianluca's research concluded that the Germans were not in the amphitheater. Radio reports claiming that the Germans were hiding guns in Pompeii were fake news. So why would the Allies unload thousands of tons of bombs onto a target of no strategic importance? Gianluca wants to find out if there could be another reason why the Allies bombed Pompeii. Franco is also drawing on historical research in his hunt for unexploded bombs. He's focused his search on Pompeii's unexcavated areas. Now he's analyzed Allied aerial photographs taken during the raids. They help him to pinpoint craters formed when the bombs landed and exploded, such as the crater filmed in the amphitheater.
Photos indicated areas that were bombed. We saw the craters of the exploded bombs, but there were missing craters.
Bombs from Allied aircraft were dropped in pairs, so should have landed and exploded together.
As the plane dropped the bombs in couples, if you see that one of the couples is missed, that it's probably that there is an unexploded bomb.
Franco and his colleague Luigi have analyzed World War II aerial photos and found some single craters missing their pair. These missing craters could indicate unexploded bombs still in the ground.
We have a very neat historical photo that clearly indicated an area with the missing craters. We selected areas that were suspicious.
They created 3D images of the suspicious areas and confirmed anomalies in the soil. These anomalies will be the focus for their search. But Vesuvius could make their difficult task even harder. A simple way to detect unexploded bombs beneath the soil is to use a metal detector. But Alessandra is exploring the impacts of the special properties of the soil at Pompeii. She investigates at the foot of Mount Vesuvius.
When a volcano erupts, the magma that is contained with the magma chamber comes out as ash, crystals, pumice lapilli. This material just flows down from the volcano and can cover completely all the area around.
Nearly a cubic mile of ash and rock rained down from Vesuvius during its eruption.
This volcanic material contains minerals that are iron-rich.
Iron is magnetic and can interfere with metal detectors that read magnetic fields. Alessandra is exploring how the iron in the soil at Pompeii will affect Franco's search. She uses a compass.
We know the Earth's magnetic field is pointing north, as is indicated by the arrow.
The arrow of Alessandra's compass is made of magnetized metal. It points north because it's attracted by the Earth's magnetic field, which is aligned on a north-south axis. But in Pompeii, Alessandra's arrow struggles to find true magnetic north because of the iron-rich soil. It's a warning that Franco's Polytechnic team needs to use its most sophisticated geophysical detection equipment to find any unexploded bombs.
This instrument is a magnetometer that is measuring the total magnetic field, and it's really highly sensitive.
In addition to the magnetometer, they also use an electromagnetometer and electrical resistivity tomography. They hammer 72 electrodes into the soil. This network will detect changes in the soil's electrical conductivity caused by unusual objects buried in the ground.
The final objective is try to relate the anomalies of distribution of electrical conductivity with some archaeological target. So we should be able to distinguish between archaeological remains and the subsoil.
The team also uses ground-penetrating radar.
GPR has a better resolution and is able to detect with high accuracy the archaeological remains. It means that bombs that have a different property from the subsoil could be detected.
The instruments are used together to see through Pompeii's volcanic soil and find the hidden unexploded bombs. A georesistivity meter sends electric pulses into the soil to detect objects that conduct electricity. The magnetometer penetrates over 30 feet into the ground to collect more data than a simple metal detector, while the ground-penetrating radar scans the soil. By combining these technologies, the team hopes to overcome the challenges of the volcanic soil of Pompeii to reveal any buried bombs. The kit has been calibrated, tested, and is now ready to go. The team can start their search. Gianluca and Franco are investigating why Pompeii was bombed. The Allies' claims of German artillery on the site were false, so they examine the Allies' aerial reconnaissance photos to find the real reason.
Il numero di esplosioni aumenta, le distruzioni aumentano, quindi ci stiamo avvicinando al target. E probabilmente il target è nella direzione ad ovest di questa zona e del sito archeologico di Pompei.
The crater pattern suggests the Allies aimed not at Pompeii, but at a different target to the west of the ancient site.
Ci aspettiamo di trovare un numero di bombe sempre maggiore che sono cadute nell'area.
On September 9th, 1943, the Allies landed at Salerno to establish a second foothold in the country. But they encountered fierce resistance and were pushed back. To protect their forces on land, the Allies pummeled the coast with their naval guns and launched wave after wave of bombing raids. Pompeii lay dangerously close to the aerial attack. Gianluca and Franco want to know if the Allied bombers were focused on a particular target near Pompeii.
Guarda, qui si riesce a leggere anche la strisciata delle bombe in questa zona, questa e questa zona, e sembrano convergere. Sì, più o meno, e sembrano convergere in questa zona.
The photo suggests the bombers had targeted sites a mile west of Pompeii.
E cioè che i target principali delle incursioni aeree erano immediatamente a ridosso di Pompei, verso Torre Annunziata.
The town of Torre Annunziata was an important hub for German military resupply. The Allies identified a critical road junction, railway line, and a factory producing steel. These were all legitimate military targets, and they were all within striking distance of Pompeii.
Intrecciando questi sopralluoghi con tutta la documentazione che sono riuscito a recuperare, emerge un dato significativo. Questo serviva per disarticolare i rifornimenti alle truppe tedesche.
Gianluca's research confirms the Allies' strategy was clear, and it worked. Torre Annunziata's supply lines were severed by the bombing, and the German counteroffensive was stopped. But Pompeii was struck by around 160 bombs. How could the Allies have missed their targets so badly? The first site Franco and his team search is on the west edge of the archaeological park, close to the Marine Gate, the main entrance to the ancient city.
This is the area with the highest density of missing predators. And so that is why it's very interesting.
The area is well away from Pompeii's excavated areas and any visiting tourists. As the team scans, one of the magnetometers picks up a telltale signal.
There seems to be something made of iron.
Franco's team survey engineer, Paolo De Bove, quickly checks the data. It's a promising discovery.
Analyzing the real-time information that we can get from the instruments, it seems that something happens and there is a magnetic response in that area.
Very strong signals, really very strong signals.
Nigel Pollard is an historian and archaeologist and an expert in war-damaged sites. He works with the team to investigate why Pompeii was bombed. He examines evidence at the American Air Museum in Duxford in the United Kingdom.
These are quite typical of the American bombs that were dropped on the archaeological site. You've got two 500-pound bombs and 1,000-pound bomb.
Around 1,400 tons of Allied bombs were dropped near Pompeii.
Just about every kind of bomb in the Allied armory was used against the targets close to Pompeii.
The Allies bombed the ancient site 9 times between August 24th and September 26th. They were targeting nearby infrastructure, but missed by at least 330 yards. How could the bombers miss so badly, with so many bombs? Nigel has special access to explore the type of bomber used in the air raids.
This is a superbly preserved example of a B-17 Flying Fortress bomber. About 12,000 of these were made.
Up to 88 B-17s flew raids in the skies around Pompeii.
The B-17 was designed for high-altitude, long-range bombing. B-17 had a range of nearly 4,000 miles and could carry a bomb load over that distance of about 4,000 pounds.
It was critical that the B-17 dropped its entire payload. Landing an aircraft with unexploded bombs on board was dangerous. Any bumps or sudden jolts could trigger a catastrophic explosion.
Typically, these bombers would try to either drop their bombs on target, ideally, or if absolutely necessary, jettison those bombs into the sea or somewhere near the target area.
The bombers that flew in from the west to bomb Torre Annunziata dropped most of their bombs. But they could have jettisoned the rest on Pompeii before flying back to base. Was this the only reason Pompeii was bombed? Chiara and Alberto investigate the two very strong signals. They check the magnetometer's data and cross-reference it against the GPR readings. Something they didn't expect comes to light.
We don't know what it is, but it's a straight feature 70 meters long. 70 meters is what we scanned. It could be longer than that.
The purple lines indicate the areas they have scanned. The yellow dots identify the magnetic anomalies deep within the soil. Whatever the team has found here is too long to be an unexploded bomb. But its length gives them a clue to what the structure might be. They suspect it could be a long-lost buried Roman road.
Well, of course, we are in Pompeii. Anything you look under the ground, you discover something of archaeological interest.
Scanning Pompeii will always be surprising. This land is full of treasures. The chance discovery is a promising sign their equipment and methodology works well, and that it can help archaeologists in future excavations here. The team moves to another suspicious area. This site lies in the northeast of the archaeological park, just 160 yards from Pompeii's fully excavated remains and tourist areas. The evidence from the aerial photography suggests another missing crater could be located here.
L'ago dello strumento oscilla leggermente verso il positivo.
One of its magnetometers detects something.
Our instruments don't tell us that it is definitely a bomb, okay? But if it is in the area that was heavily bombed, there is a high likelihood that it could be a bomb.
In Duxford, Nigel has special permission to board the B-17. He believes the interior could provide clues to why so many bombs fell on Pompeii. He explores the mechanisms used to store and drop the bombs.
Here we are in the B-17's bomb bay. You can see the bombs down here beneath us, at short, relatively deep bomb bay. And looking forward, we can see the main cockpit compartment, and then right at the very front of the aircraft, we can see the bombardier's position.
The bomb droppers, known as bombardiers, sat below the pilot inside a huge plexiglass compartment designed to help them sight their target.
Here we're looking at the business end of our B-17 bomber. Through the plexiglass, you can see the Norden bomb sight. This is the position from which the bombardier, the bomb aimer, would have aimed his bombs at the target using that sight.
The bombardier used the Norden bomb sight to drop their bombs on the target with greater precision. It was cutting-edge technology for its time. The Norden bomb sight was the Allies' secret weapon. It cost over $1 billion to develop and featured a revolutionary analog computer that constantly recalculated the impact point of the bomb. The machine could even take control of the plane's autopilot and make corrections to keep it steady in the wind. As long as the bombardier kept the target locked in their crosshairs, the Norden promised to deliver a bomb dropped from 20,000 feet to within 75 feet of the target.
This is a very sophisticated piece of equipment. The Americans went into the Second World War thinking that they could bomb very, very precisely in daylight using the Norden sight.
So what went wrong? In Pompeii, Franco and his team analyzed the suspicious signal at their second site.
Our instruments tell us there is a large mass made of iron, could be anything. It could be a bomb.
The data gathered by the radar and magnetometers indicates the metallic object they've found is just 3 feet below the surface. The magnetic signal could indicate a large unexploded bomb. The bombs dropped on Pompeii could carry up to 4,000 pounds of high explosives, enough to level a city block. And if it's a bomb with a time-delayed fuse, the vial of acetone designed to trigger it may still be intact. If they're not careful and break the vial, the bomb could finally explode with devastating consequences.
In order to ascertain what it really is, a specialized unit for bomb clearance will find out whether these strong signals are really unexploded ordnance or not.
The specialist team arrives on site and cordons off the area. They detect the exact point. Now they bring in an excavator to start the dig. Until they make visual contact with the object, they won't know what it is. Everyone watches carefully. The operation is very delicate. If there is an unexploded bomb underground, any sudden movements could trigger it to explode. So they dig just inches at a time. A sensitive task for a heavy machine like this. The team checks every layer. After a few more inches, the excavator reaches something under the ground. The investigation into why Pompeii was bombed is nearing a conclusion. Nigel thinks the Norden bomb aiming mechanism might be the culprit.
As leading-edge technology, this Norden bomb site was really expensive. They made claims in their publicity to the US Air Force and the US Navy that this thing could drop a bomb into a pickle barrel.
But this cutting-edge wartime technology was developed and tested in Southern California, where the skies are clear blue for most of the year. When the sophisticated bomb site was used in real operations in Europe's cloudy skies, the visibility wasn't so good. When the bombers flew their missions near Pompeii, the bombardier lined up the intended target using the Norden's viewfinder. The Norden then calculated velocity, altitude, and range to release the bombs. But the bombardier's initial view of the target could have been compromised by cloud cover. So some bombs were dropped too early, and instead of hitting the highway and railway junctions, they hit Pompeii.
Even the cutting edge of technology wasn't enough to save Pompeii. They caused some really severe damage.
The accidental bombing of Pompeii was an embarrassment to the Allies. They may have blamed German gun positions to cover up their mistake. At Pompeii, the excavator carefully pulls the mysterious object from the ground.
It's a piece of reinforced concrete, so we are going to remove it, and then if there is still a signal, we will see what to do.
After further investigation, the team discovers that the signal came from metal bars in the concrete. In an ancient site like Pompeii, digging anywhere can yield surprises. The team's original data suggests there is more to be found here.
There is still strong signal, so we are going to continue digging.
The data suggests a metal object lies vertically beneath the surface. The signal is just what the team expect for an unexploded bomb buried within Pompeii's peculiar subterranean strata. The specialist team takes extra care and digs by hand, but Franco takes no chances.
We found something, but for safety reasons, we have to call a specialized army unit just in case.
The Italian Army's bomb disposal unit arrives. Major Gianluca Marino is keen to check the data with geophysicist Chiara Colombero.
Buongiorno.
Buongiorno.
Sono in rosso, quindi quello che ci aspettiamo sono delle anomalie dipolari abbastanza localizzate. Sì, lo vedo, beh, ci vuole un occhio ben esperto, comunque lo vedo.
È qua, è molto simile.
The object seems to be deeper down.
Guarda la proiezione che dà, non è un cratere.
Ok.
Sei?
Sì.
È un qualcosa di profondo.
Ok.
Excavating the mysterious object is a dangerous task. Everyone not directly involved is ordered to stand at a safe distance. The team extracts a long, thin metal pole.
They found the pipe. The top of it was 60 centimeters below ground, and then it was stuck for an additional 12 feet vertically into the ground. So clearly, the strong signal was due to this metallic pipe.
It's a bittersweet result for Franco. Disappointment that he's not found an unexploded bomb, but relief that the team's work has not been in vain.
Whether it's reinforced concrete or a pipe, at least we know that this part of the park is now safe. Safe for archaeologists, safe for the visitors. And this is what really motivates our work.
Unexploded bombs might still lie below Pompeii, but as archaeologists move in to investigate unexcavated areas of the vast site, they can rely on Franco's pioneering geophysical technology and methodology to ensure they don't accidentally trigger a deadly explosion. Pompeii, struck almost 2,000 years ago by one of nature's most cataclysmic forces and struck again by allies in World War II, is safe for the future.